Hi there, welcome today to another Ask the Expert. Today we're talking IoT, Industry 4.0, and what that means for the here and now, but what it also means moving forward, such as product developments and technology. Today we're joined by Dean Donnelly from Molex, who's a Global Business Development Manager, and also Dave Pike, aka Connector Geek. And what we can promise will be a very interesting discussion. So it's over to you, Dave.
Thank you very much. Dean, welcome to DesignSpark. Before we go any further, can you give us a little bit of background about yourself?
Sure, absolutely. Dean Donnelly, I've been working for Molex for going on 23 years now. I've been involved in industrial control, specifically around systems architecture and network control from a protocol standpoint within complex machine for the last 25 years or so. So been involved in a lot of trends as it relates to early adopters from a next technology standpoint in networking and communication.
Okay. Well, we're here today to talk about the Internet of Things, but specifically the industrial Internet of Things. And we've been hearing lots about the phrases like Industry 4.0 and the smart factory. What does this mean? What does the smart factory actually look like?
Well, Craig, if you could put up that first slide, if you think about what a smart factory is, I like to use the analogy of that transition from a flip phone to a smartphone, where each device has the capability to manage its own connection to multiple applications. And what that means is, from an architecture standpoint on the plant floor, you're looking at less of a north-south communication where you have a direct segregation between IT, information technologies, and OT, which is operation technologies at a device level, and you move to an architecture that's much more open and less defined, where individual pieces of hardware are capable of having multiple personalities, where individual pieces of hardware can intercommunicate and control is distributed versus supervisory, where decision process and decision making is held by each one of those devices, streamlining, the integration of the solution and the system, as well as allowing for flexibility around those control areas.
Okay. Well, you've talked there about these devices, these devices that we're inserting intelligence into at the operational level, the factory floor. What are the challenges of getting them integrated into the network?
Well, that's a great question, David. There's, if you can go to the next slide, Craig, there's so many challenges that exist. Those challenges range from, standard architectures that exist today that have that are limited in terms of ability to communicate with other third-party devices. There's a very non-agnostic communication protocol standards that are in place regionally and supported by different governing bodies. So the ability to intercommunicate between devices that sit on different platforms is a very, very big one. But that being said, moving forward, there are technologies and there are implementations of those said technologies that we see as allowing for a more agnostic communication environment, where it's not going to matter so much what language you're speaking, but that the data is transferred, and the ability to manage that communication gap and that ability to have every device communicating in a like language is a very, very big one. Secondary to that is the ability to define and understand what the segregation needs to be from a security standpoint between information technologies networks and operational technologies networks. And that's all about managing the intercommunication between those two and managing the communication that is required to be able to pass between the two. So really, it's about combining the network, so you truly have one network, and about managing the communication so that they're all on the same language. That is the biggest. Those are the biggest steps that we see that will impede that transition timeline. But that being said, there's technologies that are being developed that will help that move along.
Okay, so that's the next step of the smart factory then. That's how these things are going to be brought together. So what does that next step look like? How can we ensure an efficient implementation of this new structure on the factory floor?
Those next steps are around intelligence development and around key core pieces of technology development, and then the associated interconnection of those pieces of technology. And from our perspective here at Molex Industrial, it's around safety, security. It's about distributing control. It's about the ability to have real machine-to-machine communication for interoperability and data package passing. It's about automation software suites that are interoperable between different platforms and different devices. It's about secure cloud connectivity, and it's about what we call provisioning. And provisioning is from an analogy standpoint. The reason we're showing on the slide here a flip phone with a standard I/O block for a standard industrial protocol versus a smartphone and a hardware platform that supports multiple networks, that supports multiple applications, that is applications based. It's really from an analogy standpoint, those next steps and those challenges are the same steps that we saw in the timing that we all saw from the point we went from a flip phone to the time we live in today with a smartphone, where that smartphone can be a GPS, it can be a phone, it can be your computer, it can be a calculator. It allows you to have all of those connections to other devices in the outside world. And that's what we see. And they're really based around the core building blocks, which are the safety, security, distributed control, machine-to-machine communication, cloud connectivity, and the ability to allow devices to acquire a personality based on what they need to be.
Okay, so you're saying that effectively the smartphone is a blank sheet of paper until you start installing those apps, and you're saying that the I/O blocks we're talking about in the future factory are going to incorporate that same personality in the same way.
Exactly, and it's not around I/O blocks alone. It's around every single device. Our long-term view of where the market is going is that, and where the applications are leading, is that each individual device will have the capability to have multiple personalities, to have the ability to manage and control its own environment from a master standpoint, yet be a slave to some other supervisory device. And that once you have that ability from a device standpoint, and once you have the ability to have an autonomous control from individual device standpoint, you can start to truly define a distributed control platform that has that flexibility that we need. Absolutely.
Okay. I just want to pick up on something. You've mentioned security a couple of times, because we're talking about a manufacturer, for example, opening up their factory floor using a common language, which is one of the things you've highlighted is different to the way it's been done at the moment. So these connections need to be secure. What needs to be considered when we're talking about these secure connections?
Yeah, that's a great question, and there's a whole lot of I don't want to call it fear. There's apprehension with respect to users or to manufacturers to allow an Ethernet connection, say, directly to the device level on a plant floor, and that's around the fear of hacking, the fear of having somebody be able to break into your network and hack the system and have production go down. And if you think about a large automotive manufacturer or a large manufacturer of any type of product, downtime is extremely expensive. There's IP there's intellectual property that sits on the network. Now that you have connection between enterprise and the device level, so there's manufacturing data, there's BOMs, and there's Gerber files if you're a manufacture of PCBA, for example. So that fear exists, and there's a reluctance. There's also a very interesting dynamic now where you have the IT departments. You've always had the IT department and you've had the OT departments, and so there's this posturing around who owns now that network, because that network is very consistent, and there's still a defined set of strategies and understandings that have to happen in order for that to be completely, melded together. But the main thing from our point of view, and my main view is, it's not really, that fear should not exist. And I think it's around, I like using analogies. It's around, if you ask anybody, it's interesting. I had a discussion with a controls manager, and I asked about their position on having a secure connection to the device level. So for access for remote monitoring, for updating of firmware packets and such on their equipment. And his response was, no, I don't trust that it'll be a secure connection. And I asked the question to him, do you do your banking online? And he answered, yes, of course I do. Well, just that open discussion and that sense of transitioning of technologies that exist in the world in which we live today to the plant floor, now that we're moving to that Ethernet, it's interesting when you look at it. Nothing that is required in order to transition to a full Industry 4.0 platform on a manufacturing level does not exist today. It exists today, and we use it in our day-to-day lives at a commercial level. And so it's about understanding that those secure levels are there and having the confidence in the technology that's already been proving out in other markets like banking, for example.
Okay, so yeah, security is something that we are all familiar with in a different environment, and it's just transferring that to the factory floor, to the industrial space, as it were.
It really is.
Yeah. We've talked a lot about data. We've talked a lot about the networking. What we've not talked about is power, because all these devices, all these new intelligent devices we're inserting into this network, they're going to need to be powered somehow. How do you see that changing with this new architecture?
So power is something that's interesting, and power on the plant floor. I think one of the first areas of opportunity within a transition in the way that's managed is by allowing better control of power when you need it and when you don't need it, and if it's not required. For example, if you have a flexible manufacturing facility and that flexible manufacturing facility has 700 robots or 1,200 robots, and they're building different versions of a different vehicle, or they're building different products on different days, depending on the flexible manufacturing cycle and what orders are coming in, you have devices that can not be used depending on what products are being made. So you have robots or CNC machines that are not being used. And the first step is managing power for cost savings. So for example, if you're not using these 75 machines, then you're going to power down the servos, and you're going to power down those servos in an intelligent way. So managing that power distribution and need versus requirement from a network standpoint. So bringing that power control via the network and managing that, I think that's the first step that we're going to see in terms of a power, changing the way we manage power on a plant floor from a benefit perspective. Taking that a little bit further, that means that each one of the power supplies or each one of the power components has network capability built in. So based on what network you're running today within your legacy control platforms, or what technology is used in the future to manage that network control platform in terms of message packet transfer, the power supplies will be capable of being adapters on that network, and then therefore be very readily controllable.
So at the moment, we've got even somebody who's got a pretty sophisticated data network. The data is all being handled intelligently, but the power is effectively dumb. It's either turned on, it's turned off. So what you're saying is this new architecture will allow us to apply the same intelligence to power in the same that we do with the data.
Absolutely, that's exactly the way we see it, and we're seeing traces of that start today. It's about how that compounds itself as we drive to that true, as I like to call it, Industry 4.0 is a revolution. It's not an evolution of the current system. When I think about Industry 4.0, I think that you can't think about the way we do things today. We have to look at what capable technologies exist in the market, like we pointed out, the difference between a flip phone and a smartphone, and we have to take those types of strides of technology, those strides of change, and apply those to the plant floor.
Yeah.
So to answer your question, absolutely, yes.
Fantastic. So sort of taking a slightly broader view now, how do we see that system architecture changing going forward?
Wow, that's something we could spend quite a bit of time on. But I'm going to go back to one of the original slides I had up, which is called Tomorrow's Architecture. I think the first step is within getting to that level. As I mentioned, it truly has to be a revolution. So you truly have to, break apart the layered view of the control platform, and that layered view is very, very defined today, pretty much across the board. When you think about systems architectures or control architectures at a plant level, there's been incremental change, bringing in pieces of technology like networks and integrated safety from a functional standpoint, and combining of or consolidating of networks. So when you think of functional safety and you think of how that changed the architecture, you can really go from having a separate safety network to having those safety devices sitting on the existing device level Ethernet network. So those incremental changes are occurring. What has to happen to really get to that next generation is for, as I mentioned earlier, each device having the capability to have its own decision making, and to have the ability to every single device be configured or be managed as a scanner or adapter, every single device to be able to manage safe and non-safe messaging from a functional standpoint, every device to have a secure remote connection for data extraction, for firmware update, for ongoing maintenance, for programming change. So it really is migrating to that smartphone view of use case, where you could walk up to any device on a plant floor and online make a connection to the cloud, download the tech sheet for that particular product, or download a firmware update, or take the digital twin of that particular device if it was damaged, and transfer that digital twin to a secondary piece of hardware that has no personality, and that hardware becomes that particular product, reducing SKUs, reducing the number of products that you have to inventory to support your system. So it really is about enabling devices the way we saw the enabling of the smartphone moving forward.
Yeah, so that's a big change from, like you say, that layered approach. So even as we've introduced layers of technology, or layers is the wrong word, but as we've introduced different types of technology, we've maintained that layered architecture. So this is a big shift away from that hierarchy into a much more amorphous, almost distributed view.
Sure, absolutely, and it's within any revolution there's going to be people that there's going to be individuals, people, or organizations that gain within a revolution, and there are always those that don't do so well in a revolution. And so current infrastructure platforms and current legacy systems and current business models, those things are changing. You look at what Amazon did to the market in general, and how it's grown, and it's grown because it brings value, and it brings, it provides services in a very timely fashion, and it's very convenient, and it has advantages that 10 years ago we would have never imagined. And the amount of times that the doorbell rings and a cardboard box gets sat down in front of the door for everybody has changed. And so that was a revolution. That was a complete revolution in terms of that approach, and I see that happening within the industrial control market. I think it won't be as quick to adopt because of the amount of infrastructure and the associated costs with making that transition from legacy-based systems to next generation systems. But I truly believe that the generational change also of those that are empowered to make decision on the plant floor is changing. If you look at, the way I view, even the way I'm looking at the market today, and the way I view those transitions occurring on the plant floor, I see myself, even for my age, as being someone that's a little forward thinking in terms of that. But when I go talk to my children who are 26 and 27 years old, and I talk to them about their view of the way the world is, and the way the world will be, it's much different. So I think that those next generations and those mindsets are going to transition this quicker than we think.
There's a couple of interesting points that I think are in here when we're looking at the transition period. So yes, for industry on the plant floor, for sure, it takes a while for that transition to happen. But what we're looking at the moment, if you're talking smart IO, for example, Dean, here, what are we looking at in terms of like the PLCs of the future? Because we've gone from the old relay boards to the PLCs. Do you see smart IO actually becoming a replacement for PLC?
I don't really see distributed control or an IO platform that has some logic built into it, or the capability to manage safe and non-safe messaging as a defined replacement for the PLC. I really don't see any of the technologies that we're discussing as a replacement for any other current technology. I view more, and I want to make something very clear. I don't believe that the entire transition from a system control standpoint and an architecture is going to move to a distributed IO platform. It's moving to a distributed technology platform. And so what we feel is that there are key pieces of technologies which are building blocks of what the next generation systems architecture will look like. And whether we talk about a PLC, or we talk about a standard IO block, or we talk about, a current, drives platform, any current technology that's being used from a device level standpoint, I don't think the goal is to replace any of those.
Mm-hmm.
The goal is to change the way in which we do it, so that the transition of adoption of technologies, someone didn't develop the smartphone to replace the calculator or the telephone. That
True.
wasn't the intention. The intention was to create a telephone, but then those technologies and those capabilities from a personality standpoint in the smartphone made those other devices redundant. It's very interesting, and I think that's a great question. And from my perspective, I don't think that we should look at trying to replace a current architecture. We should look at what current technologies exist today that can better the ability to manage a architecture, whatever that might be. And moving forward, I think there's a consensus in the market that it's built around some key technology areas that exist within a smartphone, for example, that exist on the plant floor today. It's about managing that segregation of communication. It's about, being able to define, the difference between a safe and a smart message. It's about being able to firewall effectively. It's about having measures in place so you can make remote connection and not have somebody, travel to a remote location to do maintenance on a system or on a product itself, but be able to access that product real time, anytime, so long as they have that secure connection. I view it that way, as more redundancy versus replacement.
Okay. So what are those next steps, and what are the roadblocks in getting this implemented and getting to this cloud-based system?
Well, so from our perspective, it's about investment in some key technologies and how they can be implemented in as pieces of the puzzle within all devices or in multiple applications. And the paradigm shift is defined around integrated safety and security, distributed control, seamless IT and OT integration, and focus on information models. And I think that the openness and interoperability is very, very important. So it's really around some pillars of technology, and those pillars of technology are around safe and secure sensor to cloud. So how do we manage that secure connection to either data that needs to be managed on the cloud from a digital twin of a particular product that's running on your plant or in your warehouse. It's about making remote connection and be able to securely have individuals that have the right to make a connection to a device for whatever reason, be able to do that, but keep those hackers out and be able to prove that, and to be able to support an infrastructure that allows, if there is a hack, to make that patch and to move on with limited damage or limited liabilities. So those are technologies. Those are pieces of technology from a software standpoint. Those are pieces of technology from a hardware standpoint, also around those firewalls and gateways, for example. There's distributed intelligence, so allowing open communication between devices, allowing true real-time machine to machine, and then of course some key technologies and sensors. So having every sensor that's sitting on a plant floor very cost effectively be able to support functional safety and safe. Today, if there's some key areas of technology that haven't been consolidated, so there are no ASICs, or there's no chipset, or there's no piece of technology that allows certain technology to be implemented very cost effectively. So therefore, you end up with safety devices which are much more expensive than non-safe devices, for an example. Allowing the development of technologies, for example, to get to the point where you will not have safe versus non-safe devices. Every device will have the ability to manage safe-based messaging and support all the criteria that exist within that functional safe-based application. Engineering technologies as a service are very, very important around systems, networks application, around defining executable objects within your development of a product and sharing pieces of technology. For us, that's very, very important. And then creating an environment of libraries that can be used and reused versus current control systems deployments that require to rewrite in many ways your software or your configuration platform. If you do a greenfield plant, you're rewriting the entire architecture over and over and over again. Visualization and device management, as I mentioned, device twins and digital twins of those devices. And one of the things I'd like to think about in terms of how that next generation of, let's call it, software or configuration, or how somebody interacts with their deployment of their system. I like to think about Wikipedia, and I like to think about the data that's available on Wikipedia, because you can find very accurate, extremely detailed information on almost every product, solution, topic that has ever been defined. And Wikipedia was never a company that started to try and get to that point. It was about engaging individuals that have true interest and truly want to support good information around a topic or a product or a system that they are very interested in. And so they maintain that data on their own because they had ownership of that data. They felt some connection to that data. They felt connection to providing information that is relevant and that's accurate. And that, to me, is the way in which the environment, and that's the way we're exploring an environment could be around a software, more of an open software, more of an open source view of how systems are deployed. When that will happen, I don't know, but it's something that we feel the world will get to. And when that is, I don't know, but those incremental steps are leading towards that way, we feel.
Okay, so we've got through this. What is Molex doing at the moment to prepare for the Industry 4.0 future?
We're developing, well, if you can go to the next, so I think where we are today, where we are today and our role in factory automation has always been, we've always been the experts in network communication around industrial-based protocol. So, there was a time, our SST group where I was, we supported at one time 37 industrial-based protocols from a stack standpoint, from a 7-layer stack standpoint, from scanner, adapter, and now functional safety, safety-based stacks. We're really focusing on the communication piece, and we're focusing on defined logic. We're focusing on those key pillars, the IIoT portions, secure sensor to cloud, digital twin, and device management. And so we're building technologies in very much in a building block kind of way, so that we can deploy those individual technologies to specific hardware platforms, so long as those hardware platforms meet the criteria. So for example, if you have a safety hardware platform that's TÜV certified, whether it's ours or yours, pieces of these technology pillars that are core to Industry 4.0 can be ported to those individual devices to create kind of a roadmap to that, that generation of control architecture that will be completely open and very much like, let's call it the smartphone.
That makes a lot of sense. And how do the current Molex offerings in this segment lead to Industry 4.0 at the moment?
The current offering in terms of a part number standpoint, we support all industrial-based protocols, our cabling and media systems to support the connection of each one of those networks. We have sensors that support multiple technologies that are transitioning in the market, like IO Link, for example. So our offering overall, in terms of what we bring to market today for a legacy-based system, and then transitioning to those next generation systems where it's more interoperable, has always been part of our path. And I think that's what has gotten us to where we are right now within our IAS 4.0 program, is that we've always been experts in network communication, which we're kind of that early adoption of what we like to think of as Industry 4.0. We like to think that the transition to full networks on a plant floor, and now the transition to functional safety as a standard on the plant floor, we really like to think of that as Industry 2.0, and we were always the pioneers in that area.
Well, this has all been fascinating to me. I think Greg and I both were talking about the fact that we were going to talk to you today about this subject, and certainly in our minds, bear in mind we come from this kind of world, Molex to us simply meant connectors. And the fact is that we've learned so much now about the fact that Molex isn't just about the connectors, it's about the whole integration, it's about the whole piece. I found it absolutely fascinating, and certainly this is something I'm going to look into further. The idea of digital twins is something I'm particularly interested in. So how they figure into the network of the future is something that I'm finding fascinating. Certainly from my point of view, I just want to say thank you so much, Dean, for all of your help and all of this understanding we've now gained. Greg, back to you.
Yeah, so I'd just like, thank both of you gentlemen for taking the time to join DesignSpark today and talk about IoT Industry 4.0. For me, it's been a really interesting discussion, and I think obviously with technology moving forward, we're talking about 5G, sensors and connectivity are going to be very, very important within the factory floor moving forward. So I'd just like to say thanks. It's been a really great discussion, and we'll talk again soon.
Speak to you soon.
My pleasure, gentlemen. Thank you so much for having me. Appreciate it.